days. So we have 3 months.
Oh.
Yes. So if we get our yips in gear, we can do a good job.
Are we gonna have homework on that thing we did Friday?
Thing that we're rehashing right now?
Yeah.
Yes.
Oh
We
my
are.
goodness,
All right, so we'll just call this part 2 of last week. We started exponents and radicals. So let's just rehash real quick what I mean. If I have, and I'll just use different letters right here. Let's say this is n. Let's say this is x to the m. So m and n. So this power ends up being the numerator right here on my x, and the index is my denominator. So I could go, if I divide this in half, I can go from radical to exponential, and I could, on the other side, I could go exponential to radical, and we're going to want to do, be able to do both of those. So let's say I have the 4th root of x to the 11th y cubed and z to the 8th. And I want that in exponential form. X to the 11 over 4, y to the 3 over 4, and z to the how much? Which is 2. Yes, but that's correct. And why not one more just because? Why not?
Is that x to the 7th?
Yes, yes, yes. Now on this one, there is a little trick that we're going to want to do. Whenever we have a number in here, we want to prime factorize. Just to see if anything's going to happen that we want to do. When we do, we get 3 cubed. So we're going to get 3 over 3, 7 over 3, 5 over 3. So 3 to the 3 over 3, that's just 3. But notice, for the most part, I have all the same denominators. So that's going to be important as we go from exponential to radical. So we could have an easy situation where I have like x to the 1/2, y to the 3/2, z to the 9/2. See, the denominator's all the same. That denominator is my index. So when I come over here, I'm going to have an index of 2, so I'm doing a square root. X to the 1, y to the what? And z to the... And it's so tempting to stop there, but I can't. I need to split and simplify. So I can split up that y to y squared y, and that 9 to 8 in z, which gives me y z to the 4th root xy z. Do we see how I did that? Okay. But more likely, I might have exponents that are not the same. Okay, I need a common denominator. LCD, least common denominator. And it is going to be a what?
20.
Yep. So I rewrite these so that their denominator is 20. I need the same index. So then I have the 20th root of x to the 15, y to the 12. Any questions on how I was switching from radical to exponential or exponential to radical? Either one of those. All right. Now, what we need to be able to do is use this stuff in order to simplify completely radical or exponential expressions. Okay, so let's start with 2 to the 1/2 times, let's say, 64. No, not 64. Sure, 64 to the 1/3. Let's do that. That's a good time for graduation. All right, so 64. We're going to prime factorize that. Now, you're not always going to be able to do what I just did, but do we see what I did there? So now I have a power to a power. So when I have a power to a power, I multiply and I'm going to get 2 to the 3rd. Since these bases are the same, what can I do with their exponents? Add them. All right, I'm not going to want that, leave that as 3.5. That's 7 halves. Now.
So how did you get to the 3rd power? For 2?
All right, if I had x to the 7 to the 3rd, what's that? X to the what? Okay, what if I had x to the 1/2 to the 1/3? Do you see that that's x to the 1/6?
But then that would be 6 over 3, which would be...
Oh, poopy. Yes, this should be a 2. Which means this is 2.5. Which means this is 5 over 2. Good
Oh
job.
my goodness, can you just... You need to go
I can't even divide.
We all quit. You quit.
Alright, so we have 5 over 2. I'm actually not done yet.
Wait, is that a negative 2.5?
Then why'd you start pocket?
I'm actually not done yet. I need to switch to radicals. And this is going to be important whenever my numerator is bigger than the denominator. When numerator is greater than the denominator, I'm going to need to do this. So when I switch to radicals, I have square root of 2 to the 5th, which I then split up, like so, and get for root 2.
How do you know how to switch to radicals?
Well, my hint is when the numerator is bigger than the denominator of these. Then you're going to switch to radical form to simplify further. So we could have all sorts of weird things happen. And it does get to be a horrible, horrible thing. This should be a 3/10. What do you think you would do?
Get the same denominator?
Okay. Yeah, that's a 3. Now what? I may even reduce that. Okay, so I could write it like that, or I could say the 5th root of y to the 4th. Either one of those is fine. It's when your numerator is bigger than the denominator that you're really going to want to, that you really do have to switch to radical form and simplify.
Why is there a random 3 up there?
Because I was clarifying that that's a 3.
Three. Common denominators.
The common denominator is with 10, so we multiply top and bottom by 5.
It's time for lunch, Mr. King. It's time me it's time for lunch.
It is?
Didn't you just hear it, bro?
I ran on a roll
I heard you
with
believe
the
it.
juniors go first. Everybody else
I
just.
thought it was supposed to be middle school goes first because they have to walk all the way.
The rest of high school ain't falling.
Yeah, they're just leaving. They aren't supposed to be doing that, but they are. I think Mrs. Brown just gets sick of them. Okay.
They're seniors, so they're going to go. It's what they do.
Here's a big kahuna. A kahuna's a fish,
I don't
so
like
this is a big
fish.
fish.
I don't like seafood.
You wouldn't do very well. I don't know. The big kahunas there, aren't they? Especially ones.
Alright,
What are we supposed to do?
younglings. Well, we're going to simplify. If I had x to the 5th over x squared, what would you do?
Subtract the exponents.
Yeah, so what do I get here? X to the 1/2 minus 3/4, y to the negative 1/3, what?
Minus 1/2.
1/2. Now I need a common denominator,
Why is it 3/4? That's what's on the
because
bottom.
that's what the problem is.
Oh. I knew that.
If the other common denominator is 6, and now we see, oh boy, bunch of natives. So that's going to be the other case when we switch to radicals. Okay, so far, switch to radicals when?
Numerator is bigger than denominator and negative.
When the exponents are negative. We're going to switch to radicals. So before I can switch to radicals, I am going to have to move these down. So this equals 1 over x to the 1/4, and then y to the 5/6. See, this is what makes this section so horrible, is this constant switching back and forth. So now we're going to rewrite this as the 4th root of x and the 6th root of y to the 5th. And now you see why we needed to do this, is we need to rationalize.
How are we supposed to rationalize
I'm
fractions?
not very good at rationalizing.
Fractional.
And well, it's that, well, look. The fraction becomes whole numbers here.
Oh, that's right.
Okay, so what do I need to multiply to make that x work out? 4th root of x to the what?
Cute.
And how about this y? 6th root of,
Why?
so that gives me 4th root of x cubed on top, 6th root of y, all over xy. Now, this is okay. I mean, there's nothing too horrible about this. I'm actually okay with this answer. Yeah, this is good. This is good. The book also has this as the answer. Sometimes you may want to go ahead and multiply those. We can't right here. So we're good.
That's the answer?
Yep, that's the answer. Right. We're gonna do 3 more together, and then I'll set you loose on some.
That's not gonna be pretty.
That's not the same deal.
I wouldn't want you to feel neglected.
Okay.
So you'd rather us feel abused?
I'm really
then?
confused about what is that?
Lila's getting quite the sense of humor.
That was Veronica.
Oh, Veronica. That was
That was
Veronica?
me.
So,
That was Lila.
Really?
Oh, that was Lila. Yeah. See,
Oh.
it's shocking. I have made a difference in someone's life.
I'm confused about all this denominator stuff. Like, actually, the least common denominator stuff.
All right. I'll let's see if this next one resolves that. I don't know if it will or not. We'll try. We'll try in life.
Is that a negative
Gross.
2, 3?
Yep, that's a negative 2/3.
I don't wanna. I'm done. Goodbye.
So power to a power. We multiply. So I'll do this up here. Negative 2/3 times 15. And we also have negative 1/3 times 15. But it'll be in Bible class tomorrow. Mr. Barefoot, is suicide a viable option? Math class is just killing me.
What the heck are you doing?
Alright, well I have a power to a power here, right?
So you're
So I'm showing you how this multiplies out.
Okay.
So those cancel, and I get negative 10 on top. These cancel, and I get negative 5. So I get x to the negative 10, y to the negative 5. Now this one actually wasn't too bad. I can move the x down and the y up, giving me this.
Weird. Wait, what?
Okay, but Veronica was mentioning that she wanted to see something with the common denominators.
Yeah, like, in one of the first ones you did, you had it, where you multiplied it by 10.
Okay,
It was 5.
let's say I wanted to do this one right here. What should I do with the exponents? Add them, right?
Yeah.
So I'm going to have to do 5 6 plus 1/3. But in order to do that, I need a common denominator. It's going to be 6. So I multiply that by 2 over 2 to
Oh,
get,
you want to get 6. Okay.
and now we can do that, 7 6. So this equals x to the 7 6. But in this problem, I'm actually not done. Why?
Did you gotta put it in the radical form?
And how do I know? I know I need to switch it to radical form if at the end with the exponents I have a negative or the numerator is bigger than the denominator. So I split up that x and I get x 6th root x. That's the answer to this. So that's going to be the gotcha. Okay?
Wait, can you go back to this one?
Yep. Well, I can go back, certainly.
Can you draw these out? Someone with glasses or dark room? No, that's you, isn't it?
Wait,
No, 'cause he's
wait,
smiling.
wait.
Now it's him.
There we go. Hey, that's actually pretty good.
Yeah.
Just need like a little
So-
wrinkle
so-
right here.
You need
Self-portrait?
pupils.
Actual eyeballs.
Oh, it looks like you're making you look a little crazy now.
Well, that would be true.
It's true. Okay, so now that my artwork is finished, there's two ways to do this. What if I didn't have this 1/3 here? What would you do? Yeah, so I'd get x squared minus negative 11. Now I do have this 1/3 here. And that's going to be, well, what's 2 minus minus 11? Well, 13.
Wait.
A negative negative becomes positive.
No, I can understand that. It's just the 2 minus negative 11 is.
Well, I do 2 minus negative 11. So 2 minus negative 11. That's what I'm doing right there. And I get 13. So I get x to the 13 over 3. Am I done? No! What do I need to do?
Radicalize it.
Radicalize it. Wow, what is this? A terrorist? It's a terrorist.
Yes.
And I'm going to split this up so it's divisible by 3. So we get x to the 4th cube root of x. And it is a weapon of math instruction.
Oh my
Is that
goodness.
math
Courtney, I think I found your rival.
Find what?
Her rival at puns.
Oh. I'm not even acknowledging that one as one. No.
I was thinking that we should go to the Museum of National Math History as a class trip.
Wait, there's a museum of national math history?
Absolutely. It's where numbers go that are past their prime.
Oh, come on.
You just set that up for that.
Lila was almost half excited. All right.
It's already boring. Why don't you make it even more boring with any math in it?
All right. Last example. Well, that we're going to do like in our notes together, kind of deal. I mean, I could do this one over here.
I'm not going to do well on my own ones.
Don't be self-defeating. Wait, did we already do this one?
Yep, can't do it.
Yeah, right. All right, so power to a power.
That's right, Courtney.
I'm sorry.
No time for you all to. Everyone should just graduate. So I'm just showing you right here how these cancel. Okay, and they do work out rather nicely. And I need to move that x down. And do I need to radicalize this one? No. Do not need to radicalize that one. So this one is not in ISIS. The other one was. Okay, I lied. We're going to do one more.
Got 5 minutes.
Do I really?
Yeah.
6 minutes.
Well,
this is the
his
worst.
His is a minute ahead, his computer. It actually runs at 12:05.
Or is the school wrong and my computer right?
No.
You wish, right?
That was amusing. Sisters.
Okay, so the square root of these are different radicals. Do you see this? So I can't
Do anything.
do anything there. So I'm going to have to rationalize. But before I rationalize, can I do the square root of x to the 4th?
Yes.
I'm confused which one page.
And can I do the square root of, or the 4th root of y to the 8th?
Yes.
So now I'll multiply by the 4th root of x squared to rationalize that.
Wait, isn't there still a y squared in there? At the bottom?
y. I did the fourth root of y to the 8th. So it's y squared. So it's out.
Your head's
Oh.
screwed on me.
Lila,
Lila.
don't make me come over there.
Okay.
Lila is.
I'm hungry and sleep deprived. I will fight you.
Yes, I skipped school Friday because I wanted to. You weren't sick.
Sick.
Whatever.
Oh.
I don't believe it.
All right, and then these x's cancel. So we get x, root y, fourth root x, all over y squared. And that's our answer. And then we are done.